Students, in previous class were studied preparation of ketones, physical properties of aldehydes and ketones, and then in chemical properties we were studied the nucleophilic addition reaction with hydrogen cyanide and sodium bisulfite. So today we are to discuss some more properties of aldehydes and ketones. For example, it's a reaction with alcohols, then nucleophilic addition and elimination reaction. So alcohols react with aldehydes as well as ketones in presence of dry hydrogen chloride to give gem dialkoxyalkene. Means, so alkoxy group, it's also called ether group. It is obtained from alcohol, is present on same carbon. As we know the meaning of gem that you have studied in the haloalkanes and haloalkanes, that is the two halogen atoms, that's identical halogen atoms present on same carbon are called gem. So gem alkoxyalkene are obtained when alcohol react with the aldehydes or ketones, and condition is there must be dry hydrogen chloride. So let us discuss on reaction with alcohol. Is the second reaction. Reaction with alcohol. First reaction is addition reaction. Reaction with alcohol. So aldehyde react with alcohol in presence of dry HCl. In presence of dry HCl to give hemiacetal. And then acetal. So first hemiacetal is formed and then acetal is formed. So this acetals are gem dialkoxyalkene. Acetals are nothing but not gem, not it's hemiacetal. Acetals are nothing but gem dialkoxyalkene. So it's a reaction with the aldehyde. At first intermediate, that is hemiacetal, is formed. I am writing the formula of aldehyde, RC double bond OH. It get react with the R dash OH, it's alcohol. We know ROH or R dash OH is called alcohol. RC double bond, it is called aldehyde. Reaction takes place in two steps. That is, at first hemiacetal is formed. The condition is dry HCl. It's a reversible dry HCl, hydrogen chloride. The product is here ROH. As we know, it's electronegative, so 5 electron move here, accept that electron and it become negative. This carbon become positively charged and R dash O links to this carbon, it's become negative and H to oxygen. So we have OR dash and H. This is hemiacetal. Set further react with alcohol R dash OH. In presence of same condition, it is a dry HCl. The product is R, then here OR dash H OR dash. So this is acetal. See the formula, alkoxy. The two alkoxy hydroxy groups are present on the same carbon, that is on terminal carbon. So when the two identical groups are, it may be chlorine or some other group present on same carbon, then it's called acetal. So I am writing example. CH3, CH2, C double bond OH. As we know, the number of carbon atoms are 3. So IPSC name of this aldehyde is propanol, not oil. A, propanol. Number of carbon are 3. E is replaced by R. E terminal of K replaced by R. So CH3OH, methanol. Dry HCl. So this reversible process. The product is CH3, CH2, COCH3, H, and then we have OH, then OCH3. So this is hemiacetal. When you write the IPSC name of this one, hemiacetal. So IPSC name of this one is, you have to count the carbon from this end, 1, 2, 3. This is the long chain. So should not start from here. This is because there is no continuity. We have oxygen. CH3. This carbon is attached to oxygen. So should not count this carbon. It's a substituent. So functional group is OH. On the first carbon we have OCH3. We know it's called methoxy. Then it's met with propanol. So it is 1 methoxy, propan, 1 or. On the first carbon we have OH. Set further react with alcohol, CH3, OH, dry HCl. Product is CH3, CH2, COCH3, OCH3 and H. Sets alkane, alkoxy-alkane. No functional group, no OH here. So the product is, this is acetal. In general it is called acetal. And IPSC name of this one is, this is IPSC name, I am writing the bracket. IPSC name of this one is, your number from this side, it's a 1, 2, 3. Why not from this side? Because substituents are nearer to this one. First carbon itself contains substituents. 1, 2, 3. The name of this compound is 1, 1 dimethoxypropane. Total number of carbon in the long chain are 3. Set is propane. Well, in case of ketone are less reactive, or generally they do not react at all with the monohydric alcohols. However, ketones react with the dihydric alcohol to give again dialkoxyalkane called ketone. Here it is called ketone, and in this case they are called acetal. Ketone do not react with ketones do not react with monohydric alcohol. But the dihydric alcohol or glycols, ketones do not react with monohydric alcohol. But with the dihydric alcohol, ketones forms dialkoxy, gem dialkoxy alkenes. The same carbon is gem dialkoxy alkene called ketone. So here the product name is called ketone. In case of aldehyde, it is called acetone. So condition is same, dry HCl is needed, but reactivity with the monohydric alcohol for the ketone is less. So it react with the dihydric alcohol. Example, ethylene glycol. Ethylene glycol ketone formation takes place. So I am writing equation. We know the formula for ketone RC double bond O R or RC double bond O R dash plus ethylene glycol. We have studied in the course the formula for ethylene glycol CH2H dihydric alcohol. Elimination of H2O takes place. H2O get eliminated in presence of dry HCl. It's a reversible reaction. Dry HCl. So the product is R. Then we have cyclic compound. So it is called cyclic ketone. So we have a ring shape. So it is called cyclic ketone. So we may say this is ethylene glycol. So name of the product is ethylene glycol ketone. Ethylene glycol ketone. What I have to remember is formation of acetone in case of aldehydes. In case of ketone, the product is called ketone, and one more point is it react with dihydric alcohol, not with the monohydric alcohol. So it stabilizes the aldehydes just by heating with the dilute HCl. It may be ketone or it may be acetone. You are getting the aldehyde itself. So when it is heated with dilute HCl. But when there is alkoxy group attached to the aldehyde, that is called acetone, it's a little bit more stable and less reactive. Even the oxidizing agent, mild oxidizing agent, do not convert into the, do not react with the acetones. So it acts as a protective to the aldehydes or ketones, because we can again convert that into this aldehydes by treating with the HCl. For example, you see CH3, then COCH3, so we know it's called acetone, OCH3H. It do not react with the NaOH, or it do not get react with the some oxidizing agent or some other chemicals. But when it is treated with HCl, it undergo hydrolysis to give CH3, then CHO. Same product is obtained. The original aldehyde is obtained from acetone. Drawbacks. So remember this one, it's important from the point of competitive examination like JEE, NEET, or maybe some KCET, etc. Well, after this reaction, we have to discuss about now nucleophilic addition and elimination reaction. In some it has given condensation reaction, but actually it is not condensation. At first addition takes place and afterwards elimination of H2O takes place from the product formed. So it is called nucleophilic addition reaction. In general they are called condensation reaction. So nucleophilic addition reaction is possible generally with the, already you are studied with the nucleophile. For example, with the derivative of ammonia. Derivative of ammonia means, for example, NH2OH or hydrogen, derivative of hydrogen. I will explain, I will give the formula for all these compounds. There is a nucleophilic center on nitrogen. So at first addition reaction takes place, the mechanism explains. At first addition takes place and afterwards elimination of H2 takes place from the addition product. So it is called addition, nucleophilic addition, elimination reaction. Well, now let us discuss on nucleophilic addition and elimination reaction. Nucleophilic addition, elimination reaction. So it's a third property. Nucleophilic addition, elimination reaction. Elimination reaction. Nucleophilic. So addition, elimination reaction. Aldehydes, both aldehydes and ketones, aldehydes and ketones undergoes nucleophilic addition, elimination reaction, with derivative of ammonia, Derivative of ammonia means here you have to substitute or replace the hydrogen atom of ammonia by some other group, like it is a OH or again it is NH2 or some other group. So I am writing derivative of ammonia as NH2Z. Okay, Z may be some other group. So here A with hydroxylamine. So we know hydroxyl OH, amine NH2. So it is NH2OH. What is Z here? Z is nothing but OH, NH2OH. Well, in case of aldehyde, both aldehydes and ketones react with hydroxyl amines to give the condensation product. This is because addition then elimination. So elimination takes place, condensation product oxime. Aldehydes and ketones react with aldehydes and ketones react with NH2OH, that is hydroxylamine, to give oxime. So it's the product oxime. Remember this one. Examples. So before writing examples, I am writing the conclusion. RCHO plus NH2OH. I am writing this instead of writing NH2, H2N1, and same it is H2NOH. So actually it is addition and then elimination. I am showing the elimination. No need of showing the mechanism. So you can remember more easily this reaction if you are showing the elimination of the H2O in the reaction. To give oxime RCH. So two hydrogen are removed. That means there must be a double bond between the CH or carbon and nitrogen NOH plus H2. So it is called aldoxime, aldehyde oxime. So it is aldoxime. Example is for this one. Example HCHO. We know it is called formaldehyde. HCHO is called formaldehyde. Plus NH2OH. We know elimination of H2O takes place. The product is RCH. sorry, R means H here, H, CH double bond and OH, Formaldehyde, Formaldehyde is the product. Elimination of H2O takes place, so formaldehyde, formaldehyde, in general, aldehyde. Similarly, for ketone, we know formula for ketone is R C double bond O R, or R C double bond O R dash, plus it is NH2OH, NH2OH. Elimination of H2O takes place. So the product is R C double bond, so more R's there, NOH and H2O is called ketoxide. Ketoxide. Example. We know this is acetophenol C6H5 C double bond O CH3. This is called acetophenol. Acetophenol and NH2OH. Elimination of H2O takes place. The product is C6H5. You can write the simple C6H5 instead of benzene ring. So getting full marks for that, nothing to worry. So you can write the C6H5 instead of that benzene plus H2O. Name of the product is acetophenol, acetophenoxide. Acetophenoxide. So remember, oxime is formed with hydroxylamine. We have many derivatives of ammonia. So I am writing this next one, it's B with hydrazine. With hydrazine. So formula for hydrazine, NH2, here we have one more NH2. One more NH2. So product is called hydrazone. So ion is replaced by ON. So phenyl hydrazone or aldehyde. And we have aldehyde, so it is a aldehyde hydrazone. Ketone hydrazone, like that. So aldehydes and ketones react with NH2NH2. What is NH2NH2? NH2NH2 is nothing but hydrazine to give hydrazone. So simple equation. So you have to write the equation aldehyde, then NH2NH2. Remove H2. So product is RCH double bond NNH2. The product is called aldehyde hydrazone. Aldehyde hydrazone. So example, I am writing different CH3 CHO, that is acetaldehyde. That is acetaldehyde. Acetaldehyde react with hydrazine NH2NH2. The product is CH3 CH double bond NOH and H2O. So it is acetaldehyde hydrazone. Acetaldehyde hydrazone. There may be question to write the reaction of acetaldehyde or benzaldehyde, phenyl or hydroxylamine. So you have to remember general equation, that much sufficient. In case of hydroxylamine, oxime is the product, here it's a hydrazone. So next one is ketone. So this is aldehyde, general formula for aldehyde, we know. This is a general formula for ketone. So it's a ketone plus hydrazine, NH2, NH2. The product is RCr double bond N NH2. So this ketone hydrazone. Ketone hydrazone. Ketone hydrazone. Example. So instead of prostoquinone, I want to take different example. So I am writing CH3 C double bond O CH3. So product is NH2. The product is CH3. It is CH3 double bond N OH. And we know it's acetone hydrazone. Acetone hydrazone. Well, so we can write many more examples. For example, now instead of hydrazine, I am writing phenyl with phenyl. So what you have to remember is derivative of ammonia. What is this Z? NH2 is common. NH2 is common. What is that Z? If it is hydroxylamine, OH. Hydrogen, that is NH2. Phenylhydrazine means NH is common. That Z is nothing but no phenyl and NH. So NH2 hydrazine, from one NH2, one hydrogen is substituted by, replaced by benzene ring. So it's a phenylhydrazine and formula become it's NH2 NH C6H4. You can put the benzene ring also. It's called phenylhydrazine with phenylhydrazine. So it is very easy to remember the formula derivatives of ammonia. Both aldehydes and ketones react with phenylhydrazine, that is NH2 NHC6H5. NH2 NHC6H5. NH2 NHC6H5 to give phenylhydrazine. So what do you remember? Remember the formula for derivative of ammonia NH2Z. Z may be OH, Z may be NH2 again. If it is phenyl, one nitrogen is replaced by it's a C6H5 or benzene ring. Product is it's hydrogen, except in case of it's hydroxylamine, there it's oxime. In remaining cases, it is nothing but hydrazone, phenylhydrazone, simple hydrazone, or 2,4-dinitrophenylhydrazone. Like that, we have semi-carbazide, etc. So aldehyde, phenyl. I am writing C6H5 instead of writing the benzene ring. It may be difficult to write the lengthy benzene ring equation. It takes more time. So C6H5. Then we have C6H5 again instead of hydrogen. Now H2O. Aldehyde, phenylhydrazone. Aldehyde, phenylhydrazone. What about next one? Example, benzaldehyde. Instead of acetaldehyde, I am writing benzaldehyde. Formula for benzaldehyde, we know it's a C6H5CHO. So it's a C6H5CHO. O is replaced by, substituted by, and double bond NH2. The product is C6H5, or I am writing it's a benzene ring. So benzene ring, CH double bond N OH2O. So it is benzaldehyde. This one is benzaldehyde. Benzaldehyde. I forgot to write the formula of this one. It's not NH2, C6H5. So